Hello everyone, I'm Zahid Abbas. In this video we are going to learn about L'Hopital's rule. L'Hopital's rule is a rule or theorem that provides a technique to evaluate limits of indeterminate forms. The word LHOPITAL, also written as LHOSPITAL, is pronounced as L'Hopital. The rule is named after the 17th century French mathematician Guillaume de L'Hopital. The rule is also named as Bernoulli's rule because it is believed that it was first introduced to Guillaume de L'Hopital by Swiss mathematician Johann Bernoulli. There are different indeterminate forms. Number 1, 0 by 0. Number 2, infinity by infinity. Number 3, infinity by negative infinity. Number 4, negative infinity by infinity. Number 5, negative infinity by negative infinity. Number 6, 0 times infinity. Number 7, 0 times negative infinity. Number 8, infinity minus infinity. Number 9, negative infinity minus negative infinity. Number 10, 0 raised to power 0. Number 11, infinity raised to power 0. Number 12, negative infinity raised to power 0. Number 13, 1 raised to power infinity. And number 14, 1 raised to power negative infinity. Among these indeterminate forms, the first 4, which are in the forms of quotients, are dealt directly by L'Hopital's rule. Rest of the forms are dealt indirectly. Definition. L'Hopital's rule states that limit as x approaches c of f of x divided by g of x equals limit as x approaches c of f prime of x over g prime of x, where f prime of x and g prime of x are derivatives of f of x and g of x respectively. Explanation. Let's try to understand this rule with the help of different examples. Example 1. Evaluate limit as x approaches 4 of x squared minus 16 divided by x minus 4. If we substitute x equals 4, we get 0 by 0 form, which is an indeterminate form. One way to evaluate this limit is cancellation of common factors in both the numerator and denominator and then substituting x equals 4. And the other way is using L'Hopital's rule. According to L'Hopital's rule, limit as x approaches 4 of x squared minus 16 divided by x minus 4 equals limit as x approaches 4 of 2x minus 0 divided by 1 minus 0. Here 2x minus 0 is derivative of x squared minus 16 and 1 minus 0 is derivative of x minus 4. It is equal to 2 into 4 divided by 1, and that is equal to 8. Example 2. Evaluate limit as x approaches infinity of 4x squared plus 5x whole divided by 3x squared minus 1. If we substitute x equals infinity, we get infinity by infinity form, which is an indeterminate form. According to L'Hopital's rule, limit as x approaches infinity of 4x squared plus 5x divided by 3x squared minus 1 equals limit as x approaches infinity of 8x plus 5 divided by 6x minus 0. Here 8x plus 5 is derivative of 4x squared plus 5x and 6x minus 0 is derivative of 3x squared minus 1. And it is equal to limit as x approaches infinity of 8 plus 0 divided by 6 minus 0. Here 8 plus 0 is derivative of 8x plus 5 and 6 minus 0 is derivative of 6x minus 0. And it is equal to 8 by 6, that is equal to 4 by 3. Example 3. Evaluate limit as x approaches 0 of sine of x over x. If we substitute x equals 0, we get 0 by 0 form, which is an indeterminate form. According to L'Hopital's rule, limit x approaches 0 of sine of x over x equals limit as x approaches 0 of cos of x over 1. Here cos of x is derivative of sine of x and 1 is derivative of x. By applying limit, we get cos of 0 over 1, which is equal to 1 by 1, and that is equal to 1. Hence, limit as x approaches 0 of sine of x over x equals 1. Example 4. Evaluate limit as x approaches infinity of e raised to power x divided by x squared. If we substitute x equals infinity, we get infinity by infinity form, which is an indeterminate form. According to L'Hopital's rule, limit as x approaches infinity of e raised to power x divided by x squared equals limit as x approaches infinity of e raised to power x divided by 2x. Here e raised to power x is derivative of e raised to power x and 2x is derivative of x squared. It is equal to limit as x approaches infinity of e raised to power x over 2. Here e raised to power x is again derivative of e raised to power x and 2 is derivative of 2x. By applying limit, we get e raised to power infinity over 2, which is equal to infinity by 2, and that is equal to infinity. As explained in the above discussed examples, L'Hopital's rule works well with two indeterminate forms 0 by 0 and plus minus infinity by plus minus infinity. However, for other indeterminate forms, we have to work more before applying L'Hopital's rule. Example 5. Evaluate limit as x approaches 0 of x times natural log of x. Limit as x approaches of 0 of x into log of x equals limit as x approaches 0 of log of x over 1 by x. That is equal to limit as x approaches 0 of 1 by x over negative 1 over x squared. Here 1 by x is derivative of natural log of x and negative 1 by x squared is derivative of 1 by x. By simplification, we get limit as x approaches 0 of 1 by x times x squared over minus 1, which is equal to limit as x approaches 0 of negative x. By applying limit, we get it is equal to 0. So when faced with a product 0 times plus minus infinity, we can turn it into a quotient that will allow us to use L'Hopital's rule. Let's now take a look at the indeterminate forms like 0 raised to power 0, infinity raised to power 0, and 1 raised to power infinity. Example 7. Evaluate limit as x approaches infinity of x raised to power 1 by x. Suppose y is equal to x raised to power 1 by x. Take natural log on both sides. Natural log of y equals natural log of x raised to power 1 by x. Natural log of y is equal to 1 over x into natural log of x. Natural log of y is equal to natural log of x over x. Limit as x approaches infinity of log of y equals limit as x approaches infinity of log of x over x. By applying L'Hopital rule, we get limit as x approaches infinity of 1 by x over 1. Here 1 by x is derivative of log of x and 1 is derivative of x. By applying limit, we get 0 by 1, which is equal to 0. Keeping the fact in mind that e raised to power log of y is equal to y, so limit as x approaches infinity of x raised to power 1 by x equals limit as x approaches infinity of y equals limit as x approaches infinity of e raised to power log of y equals e raised to power limit as x approaches infinity of log of y and it is equal to e raised to power 0, that is equal to 1. And this is all about this video. See you soon with the next video. Till that, goodbye.